The objective of this lesson is to develop and analyze a line plot with a fractional scale to solve a real-world task. The task reads, there were containers of punch left over after field day. Place the leftover amounts of punch in a line plot, then determine if there is enough left over for a class celebration if each person gets 2 cups of punch. The leftover amounts are 1/2 gallon, 2 pints, 1 1/2 quarts, 1 1/2 gallons, 2 cups, and 2 pints. In this task, we can create a line plot measured in gallons, quarts, or pints. There are a variety of possible answers, but for this task, we will create one line plot using a fractional scale to represent one of the possible solutions. Since the data points provided are currently measured in different units, we will need to convert each measurement to the same unit before we can plot them on a line plot. We will use a conversion table to help us in this process. Let's begin by creating a table of the amounts of punch left over. The first measurement is 1/2 gallon. Since it is already measured in gallons, we can keep the measurement as it is for the line plot. The second measurement is 2 pints. Following the conversion chart, each pint is equivalent to 1/8 of a gallon. Therefore, 2 pints is equivalent to 2/8 of a gallon, or 1/4 of a gallon. The next measurement is 1 1/2 quarts. The conversion chart shows us that each quart is equal to 1/4 of a gallon. That means 1 1/2 quarts is equal to 3/8 of a gallon. The next measurement given is 1 1/2 gallons. It is already written as a fraction, so we will include it in the table as it is given. Next is 2 cups. 2 cups is equivalent to 1/8 of a gallon. The last measurement is 2 pints. We have already converted that amount, so we can put it in our table again on the last line. At this point, we will convert the fractions of a gallon with various denominators into 1/8 of a gallon to make plotting the data more clear. Some students have a keen sense for equivalent fractions and may not need to convert the measurements into 1/8, but we will do so now. Now that we have calculated the values in 1/8 of a gallon, we can begin to construct the line plot. Looking over the data in the second and third columns of our chart, we can identify the smallest and largest measurements to give us an idea of the minimum and maximum values for the number line. With the minimum and maximum values in place, we can begin to fill in the remaining values of the scale for the line plot. After writing the scale, we will fill in dots to represent the data. We will begin with the first line of our table and mark 4/8 to represent the 1/2 gallon on the number line. We will place dots at the remaining values as well: 2/8, 3/8, 12/8, 1/8, and 2/8. The final part of the task is to determine if the class can hold a celebration and provide 2 cups of punch for each student. The task does not, however, state the size of the class. This is for us to determine. Since we know 1/8 of a gallon is equal to 2 cups, we can quickly add together the number of 1/8 of a gallon to see how many students would receive 2 cups of punch. 1/8 plus 2/8 plus 2/8 plus 3/8 plus 4/8 plus 12/8 equals 24/8. Since 2 cups equals 1/8 of a gallon, we can only serve 24 students. This means if the class in question has 24 or fewer students, the punch is enough for each student to have 2 cups. If the class has 25 or more students, the punch would not be sufficient. The objective for this lesson was to develop and analyze a line plot with a fractional scale to solve a real-world task. We met this objective by converting the data into similar units of measure, discovering an appropriate scale from the data, and plotting the data accordingly. We then used the line plot to complete the task.